like it? Okay. So this is the first part. You have 2 pages of notes. Can you find this spot in your notes, please? And the whole first page of notes is, I'm gonna say like supposed to be, because I don't think it is, but it's supposed to be review for you. But I don't think they got to this in pre-calculus last year. So it's probably not going to be review for you. It's probably gonna be the first time you saw this. So I'm going to go slow through this, but let me know if there's something that you want me to explain again. Okay, so you are starting here with this symbol. This symbol, this summation right here, means add. So if you see that sigma, which maybe you've seen this in movies on like fraternity houses or shirts like sororities or whatever, like it is a Greek letter, but it means add. So when you see that, you think add. Okay, so it means add. And then there's going to be some sort of equation here. It says sub I right there, just representing that the equation is using the letter I. If it was using the letter J or X or whatever letter, like that's the subscript here is what that means. And then the lower number and the upper number are values that you're going to plug into your equation. So whatever equation is here, I would start by plugging 1 into that equation, and then I would plug in 2 and 3 and 4 and 5, all the way till I get to what is called the upper bound. And then I would just add those all together. So this symbol means add my equation up from 1 to whatever the upper boundary is. So let's try one. So index of summation, that's just saying is the letter I. Lower bound is 1, upper bound is any number. Okay, so on this problem, my lower bound is 6, my upper bound is 10. And so I just take turns plugging in 6 all the way up through 10. Okay, so it's going to look like this. So equals 6 squared plus 3 plus 7 squared plus 3 plus 8 squared plus 3 plus 9 squared plus 3 plus 10 squared plus 3. And so that's what this symbol is telling me to do, is to add this equation up multiple times from the bottom number to the top number. So plug in 6 all the way up through 10. And you may use your calculator to type that in. You can just type, I'm going to show you that part in a second. If you just type this in, I'll show you the sigma button here in a minute. There is a sigma button, but it's a little hidden. So you're just doing like 6 squared plus 3 plus 7 squared plus 3 plus, I think it's 300 something, I think. Maybe it's. Anyone happen to have the number?
345.
345, thank you. All right, questions on the first problem? Okay. All right, second problem. We're going to plug in from 3 to 7. Let's take turns plugging my number in. 3 over 2 plus 4 over 2 all the way up to 7. Seven. 25 over 2?
Yeah.
Is that right? 25 over 2. Okay, answer 25 over 2. All right, questions on either of those first two? There is a button that you can use on your calculator that will bring up that symbol, and I'm going to find it for you real quick. Okay, so you're going to push math. Push the math button, and it's all the way down, like mine is letter, the number 0. It says summation. If you have a NumWorks calculator, I forget what that app screen is, but like
Paste, and then you want to go to calculus, and there's a summation function.
under that. Okay, so if you have NumWorks, it's on there also, but say again. Oh, if yours is disabled, you're in test mode still,
Yeah.
and we need to get that out.
How do I get
You have to hook up to a computer, which requires a cord, which I don't have the cord, but I can help you with that when I get. I'll borrow a cord.
It's also accessible.
Yours is also test mode. Darn. Okay. Well, I mean, it's not like, so if you are not in test mode and you're able to pull it up, it just brings up this. And then in your calculator, you can choose the letter that you want for your index. So you could make this an X if you want, and it would give you the same answer. If you can't get it to work right now, then you would just have to take the time to plug in 3 over 2 plus 4 over 2 plus 5 over 2 plus 6 over 2, which isn't that much longer. Okay, questions on the second one. Okay, so that was like supposed to be quote unquote review. Also, quote unquote review is properties of sigma, which are very similar to your properties of limits, derivatives, and integrals. So one of the first properties is that you can take any constant and move it to the front. And you are allowed to do that. So you could just like move your number in front, do the summation of just your little equation, and then multiply by that number later. And we'll practice that here in a second. That's the same property that we have for limits, derivatives, and integrals. And then we also have the same property where if you have a plus or a minus within your equation, then you can do the sum of the first thing plus, and then the sum of the second thing, and then add your total together, or subtract if you have a subtract. So both of those properties are true for all of the operations we've done so far, and we'll use it quite a bit for this one specifically. Okay, so practicing on example 3. Yes.
Is this gonna connect back to integral?
It will, yes. Okay, I should have said that in the beginning. So I know I said like, oh, we're doing hieroglyphics today. This will connect back to integrals, but it's going to take me like 2 days of teaching you stuff before I can show you how. But it is. Believe it or not, this does have to do with antiderivatives. Just, you got to trust the process of this one, this stuff. Will this have more problems? No, not in this context. Okay, so example 3, the property you want to use here is just saying you can pull a constant out front. Oh, here you get to practice doing your sigma. They're kind of hard to do. I try to focus on making the top and bottom parallel, but it's harder than it looks. You do need to write your lower and upper boundaries, but you can pull the 5 out and leave the I in there. You can just pull constants out. And then this could then be thought of as like 5 times, and then I just take turns plugging my numbers into I. So 1, 2, 3, and 4. And that just makes your math a little bit easier. So like this is 3 plus 3 is 6 plus 4 is 10. And so overall I get 50. And that would be the same thing if you did 5 times 1, 5 times 2, 5 times 3, 5 times 4, and 5 times 5 and added it together.
Father just like plug it into the calculator, like yeah, show.
You will not have problems this easy on the test. Right now, I'm just like showing you what it means. This, like I said, this is like what you were supposed to do last year, and we probably didn't have time. So I'm kind of showing you last year's stuff so that today's stuff is not so awful. Yes, but
Someone using the AP
you did. Maybe, yeah. This is really big in BC calculus. So like you kind of do it a little bit in pre-calc and then some here and then a lot in BC.
Could we just use the n times n plus 1 divided by 2?
Yeah, we'll do that. We'll get to that. We're getting there.
We can do that for squares and cubes.
Yeah. Okay, second example. And this is just with, I'm just kind of showing you here the property. I think at this point you guys realize you could plug in 4, 5, 6, 7, 8, 9 and add it up. But I want to show you how to use the properties. Everyone listening? Okay, so on this problem, like because there's a plus sign right here, I can split this up into 2 pieces and I can move the constants in front. So I would rewrite this to be 3 summation of I squared from 4 to 9. Plus 2 summation of I from 4 to 9. And I'm not even going to work it out because I think you guys understand the process now, but I want you to understand the breaking apart because we're going to do that when we get to the calculus portion of this after we've like kind of brushed up on the pre-calculus portion and we're doing the calculus portion. This is a really important step. So we're splitting this apart at the plus sign and we're moving the constants in front, and we'll use that property on every problem. Okay, then a couple more things before we get to our calculus stuff is then kind of going the other way is how could we take a list of numbers and write them as a sum? And this is something you would do a lot in BC calculus if you take BC next year. Is looking at a list of numbers and figuring out what the notation is for summation notation. So what I want you to do is first just draw your summation. And then I want you to look at each individual term and figure out like, what is it that's the same and what is it that's different? So when I look at all of these fractions, to me, the only thing I see that changes is this spot. The spot that changes is where your I is going to go. And so like my abbreviation for this formula is gonna be 6/1 plus I. And then my lower index needs to be the smallest number that you start with. So it's the I equals 1 to the biggest number, which would be 21. And so that's just like taking a list of things added together and abbreviating as a summation. Will you please try example 2 on your own first? So next page, try the second one. Question. They won't give it to you that way. Try example two of this type of problem. Yeah. Okay, if you want to check your answer, you should have. This is the only spot that changes in each term. So it'd be like corner brackets 1 minus I squared, putting in an I in that spot where it changes, times 1 over n. The 1 over n was in all of them. It's kind of like a weird thing to have at the end there, but that was at the end. So we put that in our summation formula. And then the lowest number was a 3 and the highest number was a 7. So that went from 3 to 7. Cool. Okay, I want to show you one more of these. That's just like a really difficult one. And then we're going to move on to a little more calculus oriented instead of review. Okay, so this is more difficult level because it gives you only the first one and the last one. So it's hard to find a pattern when there's only 2 things to look at. But I want you to still have the same thought process as looking at this and saying, well, what is the same and what's different? And the only thing between this and this, the only thing that's different is this spot. And it's not even the number 4. It's that the first one doesn't have an N and the second one does. And so that's where I need to have my variable. So it's going to be 1 minus parenthesis 4I over N. And the rest of that's all still just the same. And I'm putting the I in there. And since I doesn't show up here, it's because I equals 1. And because I is N there, it's 1 to N. And that is a harder one because if you had seen like more terms, I think you could have seen the pattern better for what 4, 8, 12. Like you could tell that you're doing 4 times something. This is just a 4 there. That's a 4 times 1. And it's a 4 there's 4 times N. Question.
You get partial credit on some.
You will not have this type of question. We're not doing the calculus part of it yet. Question.
Why would it not be into the power of the table?
And then go 0 to 1. You mean n to the power of I?
I put like I equals n to the power of 0 would be 2.
Oh, and then no, this should be a set of like integers
Okay.
instead of power. So like, and that's standard, and it'll be that way next year too. Where it's just you'll start at 1 or 0 on the bottom, and then just count the numbers up.
Okay.
So n standing for an integer.
Okay.
Yeah, I see what you're saying. Like I understand your thought process, but try to stick with just numbers there instead of something to a power.
Okay.
Okay, here's our calculus. Let's bridge this to calculus. Okay. All right, so all of that was what you were supposed to learn last year, and I know that you didn't. So like I'm not trying to rush you through that bit, but I'm hoping you can like recognize the sigma notation means add. It's like adding up a set of numbers. Okay, then bridging this to calculus. Okay, good. This is limits, which is a big throwback. We are going to bridge limits to integrals. And so one of the things we're going to look at is limits as x goes to infinity. As in a reminder, this is telling you to do a horizontal asymptote. And as a reminder of those rules, you look to see if your fraction is top heavy, bottom heavy, or the same. If it's top heavy, you get it does not exist because it goes to infinity. Bottom heavy is 0. same as A over B. And you are exactly correct. It is the same because that's the x squared and x squared. Those are the same. So you do your lead coefficients and this answer would be 3/5. Now, a few things to notice. You do not have to worry about anything besides the lead coefficient. So you don't have to worry about the minus 2x and plus 5. That doesn't matter. You just look at the biggest power of x. Okay, so on the start of the next page is a set of formulas that we have to memorize. And I know they look awful. We're going to try to at least get 2 of them memorized today. So that then you only have a couple to memorize. If you could like decorate this page and emphasize it, like you'll have to know these 4 formulas. One thing I encourage you to do is while we're here taking notes is to go ahead and what's happening right here. Is to go ahead and just write each formula down at least once. So you've got it in your mind a little bit. I don't know what I did there. I don't know that. Sorry. Oh, there we go. Okay, so that first one is just a constant. C represents a constant. So if you have a summation formula with just a constant, that formula is that you could think of that as Cn. So just take a second, write it again and think about it, concentrate on it and get it in your mind. So summation of a constant is Cn. And that only works from 1 to n. The bottom boundary does have to be a 1. But it almost always will be in our context.
Why does that work? There's nothing to.
Why does it work? There's none. Okay, so let's just say, for example, you have the number 2. And you're going from 1 to 4. When you plug in 1, there's nothing to plug in, so just do 2. When you plug in 2, there's nothing to plug in. When you plug in 3, there's nothing to plug in. When you plug in 4, and that'll give you the same thing as if you just did 2 times 4. So it's just a little shortcut to be like, oh, well, I could just multiply those numbers. Okay, second one is if you have an I. So why you, again, try to get this one committed to memory. If you can at least memorize 2 of them right now, then you only have 2 to go. So let's rewrite it. Okay, summation I equals 1 to n of I goes to n times n plus 1 over 2. So try to memorize that one right now. I'm just having you write it down so it like sticks in your brain a little bit more. And then it gets tough. So I squared. I kind of remember that one like, oh, the squared is the difficult one. It's kind of like quadratics. When you get to quadratics in your math class, it's just the hard one. It's the difficult formula also. So summation of I squared, I'm just writing it down so I can try to memorize it, is n times n plus 1 times 2n plus 1 over 6. Okay, and then last, we're going to try to memorize the cubed one. Yes, question.
Are you sure it was like derivation of those things?
I'm not going to right now, but yes, we can talk about the proof of it. We'll kind of like bridge this all together eventually when we get further in. I know it doesn't have a lot of meaning right now, but it will eventually. Okay, and then I cubed. Again, I would just write this down at least once to memorize it. N squared times n plus 1 squared over 4. Yes, question.
Isn't this one just the I formula squared?
The I formula squared. Yeah, it sure is. Yep. Oh, that's a good way to memorize. Assuming your I formula memorized, this one is just the same thing squared. That's a good way to memorize it. Okay, do you have at least like 2 of them memorized, hopefully? Okay, keep this paper on this side. Find your other page of notes. And find this problem, other page of notes. We're gonna do them together. Okay, so on these problems, I have I equals 1 to 10 of this. Okay, the problems we're about to work on, we're still not quite there where we're doing the full-on calculus problems, but we're getting there. We're almost there. This is gonna help us bridge the gap. So my steps for you are break apart as much as possible and then use the formula. So we just did those 4 formulas and I said, try to like memorize these as much as you can. So we're gonna work on the equation itself right here, like multiplying that out and breaking it apart. And then we're gonna use the formulas to answer it. I'm well aware you could just plug in 1 through 10 right now and get the answer. Yes, but that's not how we'll be able to do it when we're doing the calculus version of it. So we're just going to practice using the formulas now, and then that'll be our bridge to do the full-on problem. Okay, so I'm going to multiply this out. So I squared minus 2i plus 1. Okay, so when I say break this apart as much as possible, when we had those properties at the beginning, we said if you've got a sigma notation, you can do sigma here, here, and here. So I'm going to break this apart to be summation of I squared minus 2 summation of I and then plus summation of 1. So I broke it up into the 3 pieces, and if there was a constant, I moved the constant up front. Let me rewrite this was I squared minus 2i plus 1. So I broke it into the 3 pieces. Okay, then once you've got it completely spread apart, I want you to look at your I formulas and what you have here. So this is one of your formulas. Take a look. Do you have one for I squared? That's the hard one, right? And it's the n times n plus 1 times 2n plus 1 over 6. N stands for this top number. Okay, so it says n times n plus 1 is going to be 10 times 11 times 2n plus 1 is going to be 21 over 6. Okay, then I'm going to do minus, I'm going to carry down the 2, and I'm going to use the I formula. So that's on your other page. I is one of them that you had to memorize. It's n times n plus 1 over 2. That's going to be 10 times 11 over 2. And then this last one is a constant. This is the very first one we talked about. That goes to Cn, constant n. So I just do that number times 10. So this is going to be 10. So you use the formulas by finding a summation that has either an I or an I squared or an I cubed or just a constant, and then replace the summation with whatever it says it is with the n's. And then now we can just type this in our calculator. Yes, question. 21. That was 2n plus 1. So the formula on your page is n plus 1, 2n plus 1. Okay, did anyone get 285? Okay, now again, I know you could have gotten 285 just by plugging in 1 to begin with and like working through the numbers all the way up to 10. But this is the process we'll have to do when we're doing our calculus version. Okay, second example, very similar. We're going to break this apart as much as we can first. And so in that case, I would distribute. And now I'll just have 2 summations. So it's going to be summation of I cubed plus summation of I And then this one is a formula. So that goes to n squared, n plus 1 squared over 4, where n is 10. So that's 10 squared, 11 squared over 4. And then this one's just I, which goes to n times n plus 1 over 2. So it's 10 times 11, 2. Bless you. I'm pretty sure it's 3080 because I remember that from before, but someone check me. Yes, question. Not right now. We're about to do the really, really hard ones. Is it 3080? Okay. Thank you. Yes, questions.
You have the first one. The first one that's fine.
That if it worked numerically, it should have. I guess I never thought about that. But again, we're not going to use it in this context exactly. So I don't know that that's helpful to memorize. But all right, you ready to see the full on? So we did all that. Was just like prepping us for this moment. Ready for this moment? How do we do this in calculus? And like, I'll show you how it relates to calculus after I show you how to do it. But we're going to bring limits back and summation at the same time. Okay. So it's going to look a little bit different than what we did so far. The first two steps will be the same. Okay. So add these two steps again. And then for number 3, I want you to add in horizontal asymptotes. Okay, kind of looking at this, it's kind of like, what is that, right? Like that is so foreign. There's so many symbols there, but I want you to break it down into these steps, and I bet you can do each step individually. We're just going to like combine a bunch of the things we already know how to do. So the first thing we're going to do when we say break apart as much as possible, only leave I in with your summation. Okay. So what I mean by that is I want to keep this in with the summation. Everything else, I'm going to move out front. So I'm going to rewrite this and say limit as n goes to infinity, because I always still have to write that, summation I equals 1 to n. Or, oh, sorry. Wait, hold on. I forgot to pull out the 4 over n squared. I'm sorry. 4 over n squared summation I. And all I have done is break that apart. And by breaking it apart, now I get like a step that I can do. So the step is that this has a formula. I is one of the formulas that we have to memorize. And it's the n times n plus 1 over 2. It's a little different than what we did a second ago, because a second ago we had a number up there. Now we have a letter up there, but that's okay. You're just going to write your formula with n instead of the number. So it's going to look like this. So continue to write limit as n goes to infinity. The 4 over n squared just like carries with the problem. And then my formula, I replace the summation to be n times n plus 1 over 2. Okay, so I broke everything apart. I used my formula. Then at this point, I'm going to say you can do as many or as little as far as simplifying. I do 0 simplifying, and I'm not saying that's what's best for you to do. Like I do 0 simplifying because I make mistakes with stuff. Like you guys see me do mistakes up here all the time. And I know you guys make simple mistakes all the time, but that's because I don't know, like I just get distracted or whatever. Like I'm thinking about the next step instead and I write something down wrong. But that doesn't mean that you shouldn't simplify. Like you need to think about your own skill and like what you're best at. Like I'm better at not simplifying, but if you want to simplify, you can. So let me show you the 2 options. So option 1 is 0 simplify. No simplify. Okay. And that's what I do. So I do no simplify. And the way I do horizontal asymptotes is I look at my letters and I just have to multiply out in my head just the lead coefficient. So on the top, I recognize I have an n times n. And so I recognize my top is an n squared. And then on the bottom, I look all the way across. Everything's multiplied together. I also have an n squared on the bottom. And so without multiplying anything out, I'm able to look at that and say, instead of top heavy, bottom heavy, same, like that's the same. But if you would rather distribute this out and then multiply by 4, you would have 4n squared plus 4n. And then you'd be like, oh, yeah, n squared over n squared. Okay, so first of all, I did recognize these are the same. So if your horizontal asymptote gives you that they're the same, which by the way, it does give you the same probably 75% of the time. Not all the time, but a lot. It does give you the same. And then I look at lead coefficients. So then I have to be extra careful and say like, well, what all would be multiplied by that n squared? In this case, it would just be the 4. And at the bottom, if I multiply straight across, it would just be the 2. So I would go straight to my answer from here and say 4 over 2. And my overall answer is 2. You do not have to skip all of those steps. You could, if you wanted to. There. But you could go through and like distribute this in and make this 4n squared plus 4n over 2n squared. And then say, oh, lead coefficients are 4 over 2. It's up to you how much you want to simplify. It may be more confusing for you to skip steps. It might be easier for you to multiply out and then look. But I'm gonna give you that as an option. So from here, I can go straight to the answer and say 2, or I can distribute and then say 2. Question.
How would the summation look like?
Okay, so we'll get to that point. All right, so what is the meaning of what we just did? Okay, so we did limit as n goes to infinity, summation, where the top boundary is an n. So basically up to infinity. So it's asking me to add together numbers forever, all the way up to infinity. And it feels like your answer should just always be infinity, but it's actually not, because there are things like horizontal asymptotes that exist. And so even though you think like when I make numbers bigger and bigger and bigger and bigger, it feels like it should go up to infinity. It doesn't. Sometimes there's a top boundary and your values can actually get larger and larger and larger and larger, but still not go to infinity. And so what we're doing is we're kind of like adding up what we just figured out was an infinite addition would go to 2. If you could sit there and type buttons on your calculator forever, you would end up with 2 at the end. That's pretty tough. Can you look at that and be like, it looks really, really crazy, but I understand the steps. Like break apart, plug in the formula, horizontal asymptotes. You should definitely show your family this at dinner tonight. I mean, this is like pretty crazy. Pretty tough, I'd say. Okay, let's look at another one. Your parents would say it's easy? Would they really? Just tell them you learned hieroglyphics today, for real.
I'll be like.
Okay, let's try a second one. Okay, so first up, break apart as much as you can, which means just only leave the I in with the sigma. So my first step here is going to be limit. As n goes to infinity, I pull the 64 over n cubed out front. Summation of just I squared. And then now I have this kind of like, this piece I recognize is I squared, which is one of my formulas. I'm probably not going to see this there. So I carry down the 64 over n cubed, and then I do that formula, which is n times n plus 1 times 2n plus 1 over 6. And then here's where you get to choose how much work you want to do so that the choice is yours as long as you can get to an accurate answer. So like I said, I like to do 0 work, which is to just look at my n's here. I see 3 n's on the top, so I've got n cubed on the top and n cubed on the bottom. And then I look at the coefficients to all of the n's. So I've got like 1, 1, and 2, and the 64 up front. So I'd have 64 times 2. On the bottom, my only coefficient there would be a 6. I guess I could have made that 128, but let's cancel the 2's out. So final answer is 64 over 3. You don't have to do it that short. You can multiply out as much as you want here. You could distribute in the end, distribute the 64, whatever you want to do for work so that you can like see it clearly. Question. Yep, so on the test, as long as once you've shown your formula, then I'm just going to go to your answer and check. Yep, good question. There's not steps that are worth points there. Good question.
So college board, what is that all?
Correct. Yep. And this is going like in a direction. College Board probably won't outright ask you just to do this because there's going to be more to this eventually. And it's probably going to be a little more like application than what I'm showing you right now. Right now, I'm giving you like a microscopic view, like a laser focus of like just doing the sigma part. And then later it actually relates to antiderivatives. These are going to be the definitions of integrals, which we'll learn another day. Okay, let's do our third one. This one has a distribute in it. Okay, so it may say break apart as much as possible. In this case, I just have to distribute first. So 2 over n plus 2i over n squared. And then when I break apart, I leave anything that is an I stays in, anything that's not moves out front. So I'm going to have limit as n goes to infinity. 2 over n, summation of 1. Plus 2 over n squared, summation of I. And now I have two different formulas. Got this one, which is a constant. And that one, which is I. And so limit as n goes to infinity. 2 over n carries down. And then my formula for constant is constant times n. Hopefully that's one of them you have memorized already. So 1 times n. Carry down 2 over n squared. And then do you have the formula for I memorized now? Yes, good. Okay, n times n plus 1, good, over 2, good. Okay. They're painful, but you got to memorize them. I'm sorry. Yes, question.
So I is a constant?
I is not a constant. 1 is. It was this one. This one was a constant. That one went to 1n. Okay, now, so we're at the horizontal asymptote step where I say it's up to you how much work you do. But because of the plus sign, like right here, there's actually 2 different horizontal asymptote problems. I have to treat them separately. So wherever like your fractions are split apart, it's just, I'm looking for top heavy, bottom heavy, or the same of both. So this one, they're the same. It's end of the first over end of the first. So I get 2. Or if you prefer to cancel stuff out, you could cancel the ends out and be like, oh, I get 2. Then I do my second fraction will have its own horizontal asymptote rule. So this one has this n squared on top and an n squared on bottom. So also is n squared over n squared. So I do lead coefficient over lead coefficient. And then I add the 2 horizontal asymptote rules together. And that's my answer. Isn't it crazy that you can look at something so complex and then like break it apart into pieces? Do the pieces, get your answer. Good job, everyone. Question. All right, so let me give you your list of priorities. Hold on, let me stop this and then okay, list of priorities.